Hello students, welcome again to my channel DNA.12 Education. Today our topic in mathematics is frequency density statistics part 4. GCSE, A-Level, AS Level, Cambridge International, Oxford and IB. Frequency density. We go directly to our topic. Our topic is about frequency density, statistic part 4. Students, what is the meaning of frequency density? A histogram is drawn like a bar chart, but often has bars of unequal width. It is the area of the bar that tells us the frequency in a histogram, not its height. Once again, students, it is the area of the bar that tells us the frequency in a histogram, not its height. Students, instead of plotting frequency on the y-axis, we plot the frequency density. Once again, instead of plotting frequency on the y-axis, we plot the frequency density. To calculate this, you divide the frequency of a group by the width of it. Okay, students, look at this diagram. This is the bar chart or histogram, right? So, what will we find? Any information from this chart? Okay, at least there are two information we'll find from this chart. Students, for the y-axis, the height of this bar, we call this frequency density. And this one for the second bar chart as well, we call this one frequency density. So the y-axis is the representative of the frequency density. The next is the width of the class. Okay? This is the width of the bar. So we call this class width. Students, for the x-axis, we'll find the information a class width. So that's very clear. At least there are two information we will find from this bar. For the y-axis is frequency density, and for the x-axis is class width. Is it clear, everyone? Okay, students, to know more about this frequency density, I'll give you one example. Check it out. Frequency density formula. So what is the frequency density formula? Frequency density equals to frequency over class width. Okay, students, once again, frequency density equals to frequency over class width. We'll find that the area equals to the frequency equals to frequency density times class width. So once again, from this bar or histogram, we'll find the area equals to frequency density times class width. Is it clear, everyone? Okay, students. Now we are going to discuss one example how to define frequency density. Okay, I want to give you one example about the frequency density. A number of commuters were surveyed to find out the distances they travel to work. Draw the histogram to represent the result. Okay, this is the table. On your screen, we'll find here that there are two columns. The first column is time and the second column is frequency. How to read this table? Yes, that's right. For the time from 0 to 10, the frequency is 6. Time from 10 to 20, the frequency is 14. Time from 20 to 25, the frequency is 20. Time from 25 to 30, the frequency is 10. And time from 30 to 50 seconds, the frequency is 4. Right? That's very clear. How to read this table. Okay, now we're going to talk about the frequency density. How to define frequency density. Students, frequency density equals to frequency divided by class width. That's very clear, right? So means what's the next? The next is we have to find class width. How to find class width? That's correct. For the first row, the class width is 10 minus 0. So we'll find the class width for the first row is 10. For the second row, the time is 10 to 20. So the class width is 20 minus 10. The class width is 10. Now we go to the third row. The time is 20 to 25. So the class width is 25 minus 20. We'll find 5. The fourth row is the time is from 25 to 30. So the class width is 30 minus 25. We'll find 5. And for the last row, with the same way, we'll find that the class width is 50 minus 30. The class width is 20. Is it clear, everyone? Okay, students. Now what is the next? The next is to find frequency density. Based on the formula, frequency density equals to frequency divided by class width. Okay, students, please focus for the first and the third column. Means there are two columns to discuss. They are class width and frequency. Once again, frequency and class width. Is it clear to you, everyone? Okay, by using the formula frequency density equals to frequency divided by class width, we'll find that for the first row, frequency density equals 6 divided by 10, we'll find 0.6. Once again, for the first row, frequency density equals to 6 divided by 10, we'll find 0.6. The second row, frequency density equals to 14 divided by 10, we'll find 1.4. 1.4. The third row, the frequency density equals to 20 divided by 5, so means we'll find 4.0. The fourth row, we'll find the frequency density equals to 10 divided by 5, and we found 2.0. And the last row, frequency density equals to 4 divided by 20, and we found 0.2. So that's very clear how to find frequency density. Frequency density equals to frequency divided by class width. Okay, look at the diagram. Now, please focus to the frequency density column. Overall, these are the frequency density number. The first is 0.6. The second is 1.4. The third is 4.0. The fourth is 2.0. And the fifth is 0.2. That's very clear. That's right. Is it easy to find the frequency density? Yes, that's very easy. Frequency density equals to frequency divided by class width. Okay, students, we go to the next. Now you're going to construct the frequency density chart or frequency density diagram. Okay, based on the information, this is the table for time and the frequency column, as we mentioned before. And we got already frequency density for every row. Frequency density for all rows are 0.6, 1.4, 4.0, 2.0, and 0.2. I think that's very clear to you, right? Okay, the first is we are going to construct diagram. For the x-axis is time, and for the y-axis is frequency density. Okay, that's very clear. There are two variables that we are going to define for the x-axis and for the y-axis. Now we are going to construct frequency density versus time based on the bar as the representative of the frequency density. Okay, this is the scale. For the x-axis, the scale is 10, 20, 30, 40, and 50. And for the y-axis is 1, 2, 3, and 4. Okay, now we're going to start drawing bar chart frequency density to time. Okay, the first row. The first row or the first bar is 0.6 as the frequency density. And the class width is 10. This is the bar. That's right. Next, for the second row is frequency density is 1.4 and class width is 10. Next, for the third row is the frequency density is 4.0 and class width is 10, means from 20 to 25. Focus for this bar because the interval of time is from 20 to 25. So we have to define the bar from 20 to 25. Is it clear to you? Once again, for the third bar, the frequency density is 4.0 and the time interval from 20 to 25. Okay, now we go to the fourth bar. The fourth bar is the time interval from 25 to 30 and the frequency density is 2.0. And the last is for the fifth row. The time interval is from 30 to 50 and the frequency density is 0.2. Is it clear, everyone? So once again, for the frequency density chart, for the x-axis is for time, or the representative of time, and for the y-axis is the representative of the frequency density. For the x-axis is the interval time, and for the y-axis is frequency density. Once again, this is the frequency density. X-axis is the representative of time interval, and for the y-axis is the representative of frequency density. That's very clear, right? So this is the bar or chart of the frequency density versus time. Is it clear, everyone? Okay, students, now we go to the next. Students, I want to give you one example. This is the bar of the frequency density versus the speed. The histogram shows information about 480 cars. Okay, once again, x-axis is the representative of speed, and for the y-axis, the representative of frequency density. How many cars does the first bar represent? How many cars does the first bar represent? Okay, students, if you read the diagram or the histogram of the frequency density to speed, we found that the scale on the frequency density axis is missing. Once again, the scale on the frequency density axis is missing. Right? Okay, I give you the question mark. So what is the scale of the y-axis? No information. Okay, students, we estimate the scale of x and the scale of y are the same in square or area. Once again, the area is the frequency of this case. Once again, we estimate the scale of x and the scale of y are same in square or area. Area is total frequency of this histogram. Total area equals to total cars. Right? Total area equals to total cars. Look at the histogram. Once again, for the first bar, okay, this is the class width. We can say that the class width for the first bar is 3. Right? There are 3 scales. And for the height of this bar is 5. So we can define that the area is 5 times 3. We got 15. Next, we go to the second bar. For the second bar, the class width, let's say 1. And for the height is 6.6. And the height is 6.6. So the area is 6.6 times 1. We got 6.6. With the same way, we go to the third bar. The width is 3. And the height of the bar is 0.8. That's right. So the area equals to 3 times 0.8. We found 2.4 area. Okay, students, total area equals to total cars. So it means 15 plus 6.6 plus 2.4 in the bracket squares equals to 480. Means 1 square equals to 480 divided 24. So we'll find 1 square equals to 20 cars. Right? It's very easy. The question is, how many cars does the first bar represent? So the first bar represented equals to area times 1 square. We found 15 times 20 cars. Finally, we got 300 cars. So, how many cars does the first bar represent? Yes, the first bar represented 300 cars. That's very easy, right? Okay, students, thank you very much for your attention for this material. Frequency density statistics part 4. See you and thank you.